So there it is. I think you guys can see me. Okay. Okay, hello to all of you.
Yes, I think you guys.
Okay. Let me wait for 2 minutes. Let's say hello to each other. How many of you are there? So logged in. Okay. Hello, Derry. Mm, okay. Who else? Who else wants to join here? Yeah, Kennedy is there. Yeah. Yeah. Great. All. Okay, I can see three of you. Anyone who wants to join?
Yeah.
Okay. So many of you might have a bad connection or something like that, maybe a problem, but you can see this video offline also. But those who are in online, so the best part for them is if they have any issues, they can ask me a question there. Okay. So I think I'll start the class. Is it? So can I start now? Just tell. Hmm. Yeah. Can I begin?
Yes, I think you guys.
Okay. So I start the class. Okay. So we're talking on two-dimensional array. Okay. Now I'll go fast with the thing. Now suppose if I have a one-dimensional array of this type. So I have one element here, two, third, four, five. Say say there are example up to 6 index. So I have total number of size of this array is suppose 6. So I can have elements like 2, -1. See, this is not -1. This is suppose 7. This is something like 5 here, 8, 3, and so is -3. These are list of integers. Say we have this array which is one dimensional and it is kept continuously in a memory. So in one dimensional array we know that the computer keeps only a track of the first element of the array, that is the base address is this. So it keeps track of the first element and it has a formula by which it calculates all the next elements. We have seen this. Now it is kept continuously. Now if we want to keep these 6 elements in a two-dimensional array, say we may have something like this. Now the same thing in a two-dimensional array will be something like this. Okay. Now in a two-dimensional array it may be something like this. Okay, sorry, this is too bad. Okay, so this will be a two-dimensional array. Now we know that the index of this one is 0, this is index of 1. Now in a two-dimensional array the index of this one is 0, 0, the index of this one is 0, 1. Now this is 0, 2, 0, 3, this will be 0, 4. Oh, sorry. This is 0, 0, 0, 1. Then it goes to the next column, then becomes 1, 0, 1, 1. This becomes 2, 0. The third one becomes 2, 1. Okay. Fine. So this is the index for this one. It has only one number. In a two-dimensional array, the index is given by two different numbers. Now the same numbers I can store here in this two-dimensional array. So I'll store it like this. So it is 2, this is 7, this is 0, this is 5. Then 2705. So 1 2 3 4 5 6. Okay, let me remove this. Okay, just imagine this is not there. Okay, fine. So we have this 0 5, then 8. Oh my, this is pencil thickness is this, and minus 3. So these are the elements inside the array. So 0 0 0 1 1 0 1 1 2 0 2 1. Fine. Now this is a one-dimensional array. The same thing I'm storing in two-dimensional array. Now if you think in memory this is kept continuously, so is this also kept continuously. Okay, this is also kept very much continuously. Now it will be something like this. If we take it this in a memory, what will happen is in two-dimensional array, this one, now we may think it is kept in boxes like this 1 2 3 4 5 6, but in a memory it will be kept serially. Okay, this is 0 0 0 1 1 0 1 1 2 0 2 1. Okay, so this in memory will be kept like this. We may imagine it like a box type, but it will be kept in similar fashion. Okay, so this is 2, this is 7, this is 0, this is 5, this is 8, this minus 3 1 2 3 4 5 6. Okay, I have done again an extra thing here. Okay, let me remove this. Okay, fine. Now so index for this one is, this is 0 0. Index for this one is 0 1. This is 0 2 0. Sorry. This is 1 1 1 2 and 1 3. Okay, so now just to give you a revision. Okay, now this is a one-dimensional array by the name A. So the first element will be something called as A0, right? Second will be A1, A2, A3, A4. Now the same thing I am doing in a two-dimensional array now. This one. This is a two-dimensional array. So in a two-dimensional array, I have rows and columns. So I am storing this 6 elements in a two-dimensional array. This one, this one, this one, this one. But inside memory, they'll be stored continuously. It's not like it's a box. Memory is not. It'll be serially. 0 0 0 1 0 1 0 1 1 1 2 1 3. So 0 0 0 1 1 0 1 1 1 2 1 3. This is a serial. Memory is always serial. Again, we know that it keeps only a base address of the first elements of the one-dimensional array. Here also it will keep only the base address of the first element of the two-dimensional array. This is the base address, B. Okay, base address. Fine. Now the way I have stored here elements is, I went and completed the first row. Is it? I went first row, then I stored in the second row, then I stored on the third row. This is called row order. Okay, it's there in the slide also. Will come back. Now if we happen to store the same thing in a column order. Suppose I want to store the same thing in a column order. Okay, let me have a column order here. Again, a two-dimensional array, the same thing. Now, how did we store here is we went to 2, 7, 0, 5, 8 and 3. So we stored in the rows. So we completed the one row, then we completed the first row, then we go to the next row. Here we'll complete the first order. I mean, we'll complete the first column. So what are the elements? 2, 7. Before we stored like this, 2 here, 7 here. Now what we'll do? We'll do with 2 is here, then 7 is here, then 0. So this is column. We completed the first column, then we'll go to the next column now. So what is the next one? 5. This is 8 and minus 3. So this becomes a column order. Okay. So for a revision, this is a one-dimensional array. Its index is given A0, A1, A2, A3, A4, A5. 6 elements are stored there. The computer keeps only the base address of the first element and they are kept serially. Now for us, we imagine that this is a two-dimensional array. We are storing 6 different elements in a row order. Usually in our programming language like C, we follow row order. Okay, so we stored as 0 0 0 1 1 0 1 1 2 0 2 1. In C it happens like this, but there are languages which follows column order. Now this again, this array in memory it will be stored like this. Okay, serially this will be 0 0 1 0 1 0 1 1 1 2 1 3. Okay, now this in column order will be in memory also. It will be stored in a column order like this. So if we take the column order of this seriality in the memory, how many we have? 1 2, this is 0 0 1 2 3 4 5 6. Okay, fine. Now for this column order we have, how did we go with 0 0, then we go with 1 0. So it will be, so this will be 0 0 1 0, then 1 1. Okay, remember this is 0 0 index. Okay, now in the same row we'll have the next one, that is 0 1. This is, we go to the new row, so it becomes, row is changing. This is 1 1, then this is 2 0, this is 2 1. Fine. Now so first element stored here is 2, is it, in 0 0. Then it stores the next element 1 0, so it will be this 1 0. This is the one. Then in 2 0 index it stores this. So what is the number here in 2 index? It is 0. Then 0 1 0 2 0. Then comes 0 1 1 1 2 1. This is 0 1 index, 1 1 index, 2 1 index. Fine. So 5 8 3. So 5 8 3. Okay, so this is a row order, the below one is a column order. So if we store elements row wise, that means we complete the first row, then we go to the next row, it becomes a row order. If we store column wise, that means we first complete the first column, then we go to the next column, then it becomes a column order. So here we are completing this way, first column. So in memory also it will be stored column wise. Okay, memory is always serial. Okay, don't think like it is a box. So completed the first column, then we go to the next column like this. We are storing elements column wise. Here we are storing elements, we completed the first row. Once it is done, we go to the next row, then we go to the next row. Okay, so I just give you a pause here for 2 minutes. If you have any questions, you can just ask me. Elements. Yeah, if you have any questions here. 102021. Yeah, let me see. Yeah, just wait. Okay. Yeah, 000110112021. Yeah, it's like that. Okay. Okay, Sunny, I'll try to just give you this answer. Okay, just one sec. Yeah. Okay. Yeah, I'll give you answer. Just one sec. Okay. Okay, I'm giving the answer. Okay. See. Okay. Just one sec. Let me extend my board here. Or else I can do one thing. Create a new fresh board here. Okay. Okay. See, all of you, you just see here. Okay. This one. Now, this is a two-dimensional array here. Okay. Let me draw with a freehand. Now, can you tell me how many rows are there in this table? I mean, in this array or in this table? Yeah, there are three rows. One, two, three, and there's only one column. Okay, if I want to make two columns, suppose in this, I'll have to do it like this. So now we can say that it has two columns, okay, and three rows. Fine. So rows out here is 3, column out here is Fine. Okay. Now the first index is always row. Remember that. In a C programming language, when we write, the first index is always a row. So if I take it, this one is I, the first is I, and the second index as, we usually take it as J in programming, is it? So here I is 0, J is always also 0. So 0, 0, 0, 1. The first index is row, the second one is column. Okay. Now if I go to the next here, what happens is the row is same, only the column is changing. So it will be row is same, row is 0, the column will become 1. Okay. Now if I go next again here somewhere, the row is again same, the column is changing to 2. Fine. Now if I go here, now see, I'm going down here, suppose this, what happens here now, the row is changing. Now we are in the first row, we are coming to the second row, so the row will change from 0 to 1 and the column will remain the same, because this is the first column, the column is same. If I go here, the column is changing, the row is same, so it will be row is 1 only, the column will change from 0 to 1. Now if I go here, it's changing the first row, second row, third row, it's coming to the third row now, is it? But it is still in the first column only, so it will be 2 0 index, this will be 2 1 index. Okay. Now if I store elements row wise, say I have to store an element called 2 here, I stored here 2, I want to store some number here, I stored here 1. Now if I go with row wise, it becomes a row order. Now if I want to store 1 here, and instead that I want to store in the next row, if I store it here like this column wise, see, I want to store -1 here column wise, so it will become what, column order. That's it. Okay. So only thing you have to know here is what is a row order. When we store elements row wise, that means we complete the first row and go to the next row, that means row wise, that is called row order. If we store elements column wise, we finish the first column, then we go to the next column, then it's called a column order. Now if you want to go it row wise, we go it like this, finish the row. Okay. So I'll just give you a pause here, I hope this is okay. I have to go to the next part here now. Yeah, I hope this diagram gives you little some idea here. Zero 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 one, 10 1, 20 21. Okay. Now suppose if you have a bigger array here with bigger size, it will be something like total columns 1 2 3 4 5. Okay, rows here, suppose I have this first row, then I have here a second row, and I have here a third row. Now so what will be the this one? Then this will be 0 0 index. Fine. What will be this one? You're changing the column. Is it? The row is same, it's still in the first row. Next one will go to the third column, and the first will be 03, this will be 04. So on the first row, the row is always same, it's not changing, only the column is changing. Now if I come here, what happens? The column will, I mean the row is changing. Now it's in the first column, second row, so this will be a 1 0. Now it's in the same row, so it will be 1 1, it will be 1 2, 1 3, it will be 1 4. Now I think you can know this will be 2 0, right? This will be 2 0 index, this will be 2 1 2 2 2 3, like that. Okay, now if you store elements like row wise, first I stored the element here, some element here in this index, then I stored something here, then I stored here. If I go like this, it will be a row order. Now if I, in case if I want to store it like this, I store the first element in the first, then I go to the next row, then it becomes like a column order. That's it. Okay, I think I can proceed from here to the slide. Yeah, please tell. Okay, now I'll go to the slide here. Okay, fine, let me check the slide. This one. Now I'll not explain you what is a row order here, what is a column order here, okay, because I've done that. So you can read this, and you can read this one whole thing. What is a, I've shown you this, the simpler type of linear array, what is continuous memory location. These are the, I've already shown you, this is 0 index, this is 1 index and all. Okay, then we see that they are all homogeneous, that means all are integers here. In this test, floating points, it's a, okay, but mixing is not allowed. Say I cannot store here in between integers, I cannot store here 0.2 because this becomes a floating number. I cannot store here 1.3 because it becomes a mixed data type. So because the array elements are has to be of same type, it says. Now this I have all told you, 0 0 0 1 0 2, this 1 0. So you can see this diagram. Okay, this is a two-dimensional array, this is a one-dimensional array, this is a two-dimensional array, this is an n-dimensional array. Okay, so we have to do only two-dimensional array. This is basically, we can say that it is a three-dimensional here. So 3D is used in somewhere in movies and all. That is what we call as a three-dimensional and n-dimensional. Anyway, we'll not talk about 3, we'll talk about only 1 and 2. Now length we have already seen, we have found with this formula. Okay, then find the length, we have done this one. So the base address, I have told you that computer takes only the base address, this one BA, that is one-dimensional array. Okay, I've shown you this problem. Can you find this 1965? You can see the answer in the notes. You can check this in the notes. It's there. Okay. Okay. So an array is called, so coming to a two-dimensional array, is called two-dimensional in which each element is referred by two subscript. So the subscript we have seen, is it? One is I and we call it other one is J usually in program. So we have seen those subscripts are 0001. We have seen just now. Okay, or index. Subscript or index is same thing. Now usually starts from, in writing theory they write it as 1. Okay, but in programming language we always starts array from 0. We know that, so there's not a point here, there's not much of difficulties here. So this m is called the row, this n is called the column, number of columns. So it is less than, that means the number of columns is always, I mean the index is always less than the number of rows, which is always greater than 1. Okay, then this column index is always greater than n and is always greater than 1. Right, and it's usually written as like this. The notation we follow is this one, or sometimes we write it like this inside bracket. A two-dimensional array also called matrices, which you must have seen in mathematics. Okay, that's a two-dimensional array. Now explain the representation of a two-dimensional array in memory. So let A be a two-dimensional array. So that's the question sometimes they ask, of m cross n array. Now although A is pictured as a rectangular array of elements with m rows and n columns, the array will always be represented in memory in a block of m cross n sequential location. Now this one, what I mean is, now this one what I mean here is, suppose this is an array 0 0 0 1 0 2 0 3 0 4. Okay, now you may imagine it as rectangular. Okay, but in the memory location it will be always stored serially, it's not rectangular. Okay, so if I take this, suppose this array, suppose if only this array is there, now we may imagine it as something like a two-dimensional array, is it? And it's kept in a rectangular box, but in memory it will be serial. So we have something like, how many locations? 1 2 3 4 5 6. So 1 2, in memory it will be kept serially. 4 1 2 3 4 5 1 2 3 4 5 6. Yeah, so six different locations are there. Okay, so the first one is, sorry, the first one will be, this is 0 0. The next index will be 0 1. It's kept in a serially in an m cross m dimension. 0 1 0 2 in a row order usually, which we follow. Then 1 0. C programming puts arrays like this in memory. 1 2. It looks like in a one-dimensional array, but it's a two-dimensional. So how it breaks is, how does it do the breaking is, it takes from here till here, it will take this one as one array. So it will take that part from 0 0 0 1 and 0 2. Then from here it'll put it as like this. So it becomes a two-dimensional array. Okay, so it says that, just if you see the slide you can notice here something. It says that of block of m multiplied by n sequential memory locations, means m cross n means we have how many rows here? 1 2 3. Is it 3 rows? Sorry, 3 columns. I mean rows here is 2. Sorry, this is the first row, this is the second row, That is m is 2 multiplied by columns 1, 2, 3. So it is m cross n. So how many? 2 multiplied by 3 is 6. So 6 number of elements which is kept serially in memory like this. Okay. So that's what it says. It's a block of memory of m cross n or m dot n sequential memory locations. So 2 dimensions arrays are kept that way. Fine. This is a sequential memory. This is a sequential memory here. Okay. Let's write in sequential. Okay. Sort. This is sequential memory here. This is the array which is we visualize as a matrix, but in memory it will kept as a sequential memory like this, which is m cross n. So 2 cross 3, which is number of elements here is 6. Okay, now going to the next slide. If you have any questions here, the last part is left in case if you have any questions or any confusions anywhere. Okay, I suppose there is no question. I'll go to the main part here. Okay, now this slide, specifically we have seen that a programming language stores it by column, which I've already shown you, or a row by row order. Okay, Now for a particular representation, use depends upon the programming language we use. It does not depend upon the user. We cannot decide we want to store in a row wise or column wise. It depends upon the language. Usually in C it is row wise. Okay. Now the same thing it says here. The first column 1 1, then it goes to the 2 1 3 1 like this. In case of a row, this is 1 1 2 1 3 1. This is the first row in a row major. Okay, and this is the column major. Okay. Anyway, if we don't need this diagram, it's not that important for you right now. Okay, whatever I have shown you previously in a row major and column major, whatever happens, you can just give that. If it stores row wise, it become row. If it stores column wise, it column. Now in C language, it is row wise. Anyway, now recall that when calculating the element address of any element, we know that the computer keeps only the base address LA. Then we use this, is it? Base plus with k minus 1. Now there was only one index here. Okay, this k. But now we'll have in a two-dimensional array, we have two different index. In case of a row major, we have this base plus with multiplied m whose address you want to form. This is the address of the location whose element is supposed to be found. K minus 1 j minus 1. If it is a row major, then instead of m it is n, that is j minus 1 k minus 1. We have to remember this formula. Now in case of column major, it is m. In case of row major, it is n. The array is m cross n. Okay, m means the number of rows, n means the columns. Okay, so in case of a row major, we use the column major, we use this m, which is given by a row. In case of a column major, a row major, sorry, we'll use this n. K minus 1 j minus 1. Here it is j minus 1 plus k minus 1. The same thing, not a. Here m is multiplied by k minus 1. Here n is multiplied by j minus 1. That's the only thing. Okay. Now in computing, this row major and column major describes the method of arranging multidimensional arrays in linear storage memory. In row major, consecutive elements of the rows are stored continuously in memory. In column major, continuous elements of the columns are stored in continuous location. Okay. We say that the matrix is row major order if it is stored row by row. That means the first row is stored first, then followed by the second row. And we say that it is column major. Same thing. Okay. So in case of a column major order, we have this address is given as like this: base plus w m k minus 1 j minus 1. This one you have to remember. The row is m cross n. Okay, that means in case of a column 1, we'll use this m. In case of row, we'll use this n. So it is k minus 1, which you have already seen here, n plus j minus 1. That's the only thing you'll have to put. This LOCAJK is the location of the ith and the jth column we want to find. Which location we want to find? Base address is the base address of the first array of the memory. W is the bytes. M is the total number of rows in the array. J is the number of row element. Okay, and K is the column number of the element. So is same thing in this formula of row major. Okay. We have an array here like this: 1 1. It starts from 1 1 base, 2 1 3 1 1 2. The base address is 1000. So it's given 1 1 is stored in location 1000. 2 1 is stored in 1002. 3 1 is stored here in this one. Find the location of 3 2. So we'll have to find somewhere here will be 3 2. So base address is 1000, W is given 2, M is 3, J is 3, K is 2. Now, in case if we want to find this in a column measure, what we'll have to do is the same thing. Base address plus width is 2, 3 minus 2 minus 1, this K is 2, J is 3 minus 1. Okay. Now do the same problem using row order. If you can do this, or if you can search one or two problems on the net and you solve this one, you can do this. So I have given you this problem which is being solved using a column order. So in case of row order, you'll have to put m cross n. So the array says it is 3 by 2. Okay. So you'll have to decide what is the value of n here. Okay. Okay. Do the same problem using row order. Okay. You can take n as suppose 4, or take say n as 3 only, no problem. So it will be same thing. 3 j minus 1 k minus 1. You just have to fit this. That means this will come here, this will just goes there. Okay. So this is how we do a calculation. We'll do some more problems related to this one. In the meantime, what you have to understand is you'll have to know this formula. For a column measure, this is m k minus 1 j minus 1. For row measure, this is this. So this will be clear to you when we do exactly the problem. So I'll solve one or two problems with this one, and this is important. Sometimes they ask in exam. Okay. So I stop here. If you have any questions. So okay then. Thank you and good night. Okay then. Yeah. Thank you all.